Section 4. Wave-particle knowledge action. A third major feature of quantum physics is complementarity. This is associated with the uncertainty principle and is attributed to Niels Bohr. At one level, this views microentities as having dual natures, as being both particles as waves. As particles, they may have precise position, but not precise motion or momentum. As waves, they may have precise momentum, but not precise position. In quantum physics, Zohar explains, both waves and particles are equally fundamental. Quote, each is a way that matter can manifest itself, and both together are what matter is. And while neither state is complete in itself, and both are necessary to give us a complete picture of reality, it turns out that we can never focus on both at once, end quote. And as Hodgson puts it, quote, experimental arrangements for precise measurement of one aspect, say position, preclude those for precise measurement of the other aspect, momentum. So no incompatibility can arise in practice, end quote. Hodgson also comments that, quote, Bohr's philosophy of complementarity suggests that in areas where our concepts are inadequate, it may be necessary to use two modes of description of an entity which are mutually exclusive, yet involve no practical inconsistency, in that the conditions under which the entity is manifested under one description preclude the possibility of its manifestation under the other description, end quote. Bohr saw this view of microentities as having dual natures as an analogy applicable to the brain-mind. In other words, when the brain-mind is observed and tested as a physical object with physical processes, its manifestation as conscious mind would be precluded. Quote, thus, the brain-mind may have two apparently contradictory aspects, as a mechanistic physical object and as a free-willing mind, which cannot simultaneously be displayed, so that no incompatibility can arise in practice, end quote. We shall see later this possibility is key to Hodgson's own theory of mind. Zohar seizes on the principle of complementarity as the, quote, most revolutionary statement that quantum physics makes about the nature of matter and perhaps being itself, end quote. It follows from quantum's description of the wave-particle duality, quote, the assertion that all being at the subatomic level can be described equally well either as solid particles like so many minute billiard balls, or as waves like undulations on the surface of the sea. Further, quantum physics goes on to tell us that neither description is really accurate on its own, that both the wave-like and the particle-like aspects of being must be considered when trying to understand the nature of things, and that it is the duality itself which is most basic. Quantum stuff is essentially both wave-like and particle-like simultaneously, end quote. She adds that this Janus-like nature of quantum being entails that, quote, each way of describing being as a wave or as a particle complements the other, and that a whole picture emerges only from the package deal. Like the right and left hemispheres of the brain, each description supplies a kind of information that the other lacks. Whether at any given time elementary being displays itself as one or the other depends on the overall conditions, crucial among which whether or not anybody is looking, or when they are, and what they are looking for. In addition to indeterminacy, uncertainty, and complementarity, a fourth feature of quantum mechanics, which tends to undermine the classical approach to physics, is holism. This is the theory that the whole can be regarded as greater than the sum of its parts. This is because the parts of a whole are in intimate interconnection. They cannot exist independently of the whole, nor can they be understood without reference to the whole. In relation to this, Hodgson says of quantum theory that it implies that, quote, the behavior of composite systems is not always a function of, or calculable from, or caused by the behavior of the component parts of that system, which can themselves be understood in isolation from the whole system. In at least certain situations where micro-events are measured, the behavior of component parts of a composite system is rather a function of the behavior of the whole system. This is perhaps most clearly illustrated by the aspect experiments concerning the Bell inequality. Stapp makes a similar point by claiming that each physical event, quote, has both a psychologically described aspect, which is essentially an increment in knowledge, and also a physically described aspect, which is an action that abruptly changes the mathematically described set of potentialities to one that is concordant with the increase in knowledge. This coordination of the aspects of the theory that are described in physical/mathematical terms with aspects that are described in psychological terms is what makes the theory practically useful. As Stapp points out, this means that the proper subject matter of science is not, quote, what may or may not be out there, unobserved and unknown to human beings. It is rather what we human beings can know and can do in order to know more, end quote. As he explains, the founding fathers of quantum mechanics, in formulating their new theory, focused on the knowledge-acquiring actions of human beings and the knowledge acquired by these actions, rather than around a conjectured, causally sufficient mechanical world. From having previously ignored our knowledge, the thrust of physical theory shifted to become essentially about our knowledge. And this included, according to Stapp, a concern with, quote, the effects of the actions that we take to acquire more knowledge upon what we are able to know, end quote. The main actions referred to here are, of course, measurements. Stapp elaborates on this new quantum conception by explaining that, quote, the physically described world is built not out of bits of matter, as matter was understood in the 19th century, but out of objective tendencies, potentialities, for certain discrete whole actual events to occur, end quote. The French physicist Bernard de Spagna again stresses the mental aspect of this process and introduces the notion of a deep or veiled reality. He claims that the world of observed macroscopic objects, including brains and brain cells, is a construct of the human mind. This construct, he continues, is built up from regularities in observed phenomena. But in contrast to classical physics, he is not referring to regularities in physical reality. Rather, these are the regularities of a deeper or veiled reality, which cannot be equated with either to the physical notions of everyday life, nor even with localized mathematical entities.